Lecture 8. So today we're going to start talking about polynomials. Let's understand those terms. So this will have a degree of polynomials and leading term, leading coefficient. So this is a polynomial, right? So how many terms? Poly. Poly means many. Poly means many. Nomial means terms. And typically, nomial means one term. So what is a term? So in this polynomial, so this is a term, this is a term, this is a term, this is one term, this is one term. So we have here 1, 2, 3, 4, 5 terms. And this term is positive. This term is negative. This term is positive. This term is positive. This term is negative. So we're adding all those terms together. So adding this positive with this negative with this positive, this positive with this positive, this positive with this negative. So we're adding all those terms. And together we call polynomials. So each one is a term. So this, even this one, we have 4, we have x cubed, we have y squared, but this is considered as a monomial. So let's understand this is a monomial. Mono means one. So each one is a monomial. Then when we have 2 terms, we call binomial. Bi means 2. Binomial. Okay. If we only consider these 2, we only consider this 2 as a binomial, 2 terms. Then 3 terms called a trinomial. We need that. Tri means 3. Trinomial. When we talk about polynomials, we talk about degree of polynomial. What is a degree? Degree is the highest exponent among those terms. So degree is the highest exponent of all terms. So in this case, let's see. So let's start from low. The degree of A is a 0 polynomial. Why? Because that's a variable raised by 0 power. Remember, anything raised by 0 is 1. So 1 times A is still A. Of course, this is negative A. So this is a constant. Okay? So negative A is a constant in this polynomial. Constant is a degree 0 polynomial. Okay, then 3x, this term is a degree 1 because x is x raised by 1, so degree 1. And this term, we have 2 variables. We have x raised by 2, we have y raised by 1. So when we have 2 variables, we add the exponents. That becomes that degree. So degree of this term is a 3 because 2 plus 1, because exponent of x is 2, exponent of y is 1, 2 plus 1 is a 3. So degree of this term is a 3. Degree of this term is 4. Because x raised by square, y raised by square, 2 plus 2 is 4. So that's the degree of this term. And degree of this term is 5. 3 plus 2 is 5. So let me change my color. So the degree of this polynomial is the highest one. It's 5. So we see this, the degree of this polynomial is 5. Okay, we'll take the highest exponent. So when we have 2 variables, we add the exponents, that becomes degree. So 3 plus 2 is 5, degree 5. Then the leading term is the term has the highest degree. So in this case, 4x raised by 3, y squared is the leading term. Leading coefficient is the number in the leading term, in this case, which is 4. So degree of polynomial is 5. Degree, the leading term is this one. The one has the highest exponent. The one has highest degree. Then the leading coefficient is a number in front of the variables of the leading term. Right, so that's the first one. Now let's look question 2. Use the leading coefficient test to determine the end behavior of each graph of each polynomial function. Okay, so f of x before we call y, right? Call y equals to x cubed plus x minus 5. But now in the function world, some equations are functions. So this is a function, so we write as f of x. Basically saying this is a function, this function is determined by the value of the input x. How is it defined? Is cube it, raise the input by 3, power 3, and plus the input minus 5. So this is a polynomial function, and the degree is 3, because the highest exponent is 3. The degree, this is the leading term, and leading coefficient is 1, because this is no number, by default is 1. And this is a constant term, -5, degree 0. X is a linear, degree 1. Right, so this is a degree 3 polynomial. All right. So what is the leading coefficient test? Two parts. So polynomial either have even degree or odd degree. Or odd, let me allow me to draw here. Odd degree. So we have seen this is odd because the degree is 3. But this one degree is even. X raised by 4, so 4 is a degree. It's even. So if it's odd polynomial, if the leading coefficient is positive, let's call the leading coefficient a number 8, right? If it's odd, if and the leading coefficient is positive, so the end behavior is this. It goes through the first quadrant, it goes through the third quadrant. That's the end behavior. So how do we use algebra to represent? This is in when x value goes to positive infinity, because that's in this direction, right? See here, it goes to positive x and positive y. So the function value also goes to positive infinity. Because you see this, if we draw a little triangle here, you see this goes this way, horizontally goes this way to positive infinity, vertically goes to positive infinity also. That's the end behavior. For odd degree polynomial, leading coefficient positive. And on the third quadrant, if x value goes to negative infinity, and the function value also goes to negative infinity, right? Because you see x value goes to negative infinity, and y value also goes to negative infinity. So that's the end behavior for odd degree and the leading coefficient positive. If leading coefficient negative, let me finish even one. If it's an even degree, the end behavior is this, because of the second quadrant and the first quadrant. The first quadrant is similar to this one, right? X goes to infinity, and the function value also goes to positive infinity. And this one is the same. When x value goes to negative infinity, the function value goes to positive infinity, right? You see, if we draw a triangle here, x goes this way, but the y goes upward. So that's for even degree. Now let's use red color. This is also for positive, even degree, positive leading coefficient. Now let's see leading coefficients negative for R degree. If it's R degree, leading coefficient negative, we'll have this. Go second quadrant and the fourth quadrant. This is in x goes to negative infinity, but the function value goes to positive infinity. This is in x goes to positive infinity, function value goes to negative infinity. Okay, you see this x value goes this way, positive infinity, but the function value goes down. And for even degree, if the leading coefficient is negative, we have this. Right? And this is in x goes to negative infinity, function value also goes to negative infinity. This is in x goes to positive infinity, function value goes to negative infinity. We have those four situations. Okay, let's see A. A, we have R degree positive leading coefficient. So the end behavior is this blue color, right? So go through the first quadrant and the third quadrant. In the middle, we don't need to draw anything. We just draw the end behavior. In B, we have even degree, but negative leading coefficient. So that's the red, that's this one, right? So that's this red color, the leading, the end behavior. C, what is the degree? Degree is 1. Well, 1 is an odd number. Okay, so this picture. And the leading coefficient is -1, so it's negative. So it's red color. Goes through the second quadrant and the fourth quadrant. D, even degree, but a positive leading coefficient because by default this is 1. Right, so we'll go back to this even one and with blue color. This is the second quadrant and first quadrant. You can also think the even degree with the even with a positive leading coefficient is like both hands up. Okay. If the negative leading coefficient, both hands down. If the R degree positive leading coefficient, you have right arms up, left arm down. If the negative leading coefficient, you have left arm up and right arm down. I think that way too. Okay. Now let's go to 3. We want to perform the indicated operation. In this case, indicated operation is plus. So have this polynomial degree 3 with a negative leading coefficient. And we have this polynomial, also degree 3 with a leading coefficient in positive. So how do we perform? How do we add those two polynomials? We're looking for like terms to combine. Like terms means they have the same variable and the variable have the same exponent. So in this case, we see -3x cubed and the 7x cubed. Those two are leading like terms, right? Because they have x raised by 3, x raised by 3. Now the leading coefficient is -3 and 7. Think what's -3 plus 7? Well, that's 4. Right? So we have 4x cubed from x raised by 3 terms. Now, second one, we have 2x plus nothing, no x in this case, right? But then we observe the second polynomial have -3x squared. But the first one, we don't have x squared term. So that becomes just -3x squared. Then plus 2x. Then we see 5 in the first polynomial plus -8. 5 plus -8. Well, that's -3. So -3. And that's it. So we're adding two polynomial degree 3. We're still getting a polynomial degree 3. Okay, this degree 3 term, degree 2 term, degree 1 term, degree 0 term. Well, second one, B, is minus 7x cubed minus -2x cubed. Think about 7 minus -2. That becomes 7 plus 2, which is 9. So we have 9x cubed. Then we look for square term of -5x squared minus 5x squared. So we're thinking -5 minus +5. Minus positive, that's minus. -5 minus 5, that's -10. So we get a -10x squared. Then we look at x term of 2x minus 1x. So 2 minus -1, right? Because this by default, that's -1. That becomes 2 plus 1 equals to 3. So get plus 3x. Then we have 1 minus 5. 1 minus 5. That's -4. -4. So you see, we identify like terms. Once we identify like terms, we just perform the operation to their coefficient, to the number before it. We're like -3x cubed plus 7x cubed. Let me write here. -3x cubed plus 7x cubed. Right. So we identify those two are like terms because both have x cubed. Then the operation just upon their coefficient. So just add -3 with 7, get -4. All right. Now let's see 4. Find each product. Now we multiply two polynomials. So this is a polynomial, this is a polynomial with two variables. Multiply them. How do we multiply? We multiply number with number. So 7 multiplied by -2, we can reorganize. Then the first one has x squared. Second one has x raised by 4. Y raised by 5. Y raised by 2. So 7 times -2, -14. X squared times x raised by 4. Same base, we add the exponents. So x raised by 6. Y raised by 5, y squared. 5 plus 2, 7, y raised by 7. That's it. That's the answer. Now let's see B. B, we're multiplying monomial with a trinomial. Right, here we have 3 terms. Here's only 1 term. So what do? We just multiply, we distribute. We multiply the monomial with everyone inside the parentheses. So let's rewrite it. So we have 5x squared times 2x cubed, then plus 5x squared times -x squared, then plus 5x squared times 3x. All right. So you see 5x squared is monomial multiplied by the first one inside the parentheses, multiplied by the second one inside the parentheses, multiplied by the third one inside the parentheses. In mathematics, we'll call this distribution. So multiply those two, multiply number with number. 5 times 2, 10. X squared times x cubed, x raised by 5. 5x squared times negative, that's -5, x raised by 4. Then 5x squared times 3x, that's 15, x cubed. We still get a trinomial. C, we have binomial times binomial, right? Or 2 terms times 2 terms. So how do we multiply? We do double distribution. We multiply those two, we multiply those two. Then we multiply these two, we multiply these two. Multiply x with x, we get x squared. Multiply 2y with a negative 3y, we get a negative 6y squared. Multiply 2y with x, we get a 2yx. Multiply x with negative 3y, we get a negative 3xy. You see the beauty of this is these two are like terms. So we can combine these two like terms. 2xy minus 3xy. That's minus 1xy. So then we have x squared. We also have minus 6y squared. Okay, so when we multiply 2 with 2 binomial times binomial, we get a trinomial. The two middle terms can be combined. Let's see D. D will have a binomial multiplied by a trinomial. Right? Still do double distribution. We can multiply x with the first one, x with the second one, x with the third one. Then we multiply 2 with the first one, 2 with the second one, 2 with the third one. So basically this, we do x times x squared minus 4x plus 1, then plus 2 times everyone inside of parentheses, double distribution. Multiply x with everybody, we get x cubed minus 4x squared plus x. Multiply 2 with everyone, we get 2x squared minus 8x plus 2. Then we combine like terms. We have x cubed, only x cubed doesn't have like terms, so we get x cubed. Then we get a negative 4x squared, positive 2x squared. That combined to be negative 2x squared. Then we have an x from negative 8x, that's negative 7x. Then we have this 2 plus 2. So we get a polynomial degree 3. Next one, we factor polynomial. Get 5. Okay, 5, we want to factor greatest common factor from this polynomial. Let's see the first one. We have 3 terms, right? So this is trinomial. So this term, this term, and this term, 3 terms. So we see 2 is a common factor, right? Because this is a 2x times x squared. And this one can be think as a 2x times 6x. And this one is 2x times 8. So we see 2x is the greatest common factor. So we factor out 2x. The first one we left with x squared. Second one we left with negative 6x. And third one we left with 8. Then this one, this is a trinomial. This trinomial can still be factored. Can factor to be negative 4 and negative 2. Right? So how do we factor this way? We think about two numbers, a times b equals to 8. A plus b equals to negative 6. Negative 6 here, a is here. And that's negative 2 and negative 4, right? Because negative 2 times negative 4 is positive 8. Negative 2 plus negative 4, that's negative 6. So this trinomial factored into 3 factors. This is a monomial factor, this is a binomial factor, this is a binomial factor. Now let's see B. 21, 14, we see 7, right? X in both places, X is here, X is there, Y is here, Y is here. So let's factor out as 7xy. Then the first term becomes 3y squared. right? Then plus second one, let's factor 7xy. Then that becomes multiplied by 2x squared. Now 7xy is common factor. So factor out 7xy, we have 3y squared left for the first one, then 2x squared left for the second one. And then this cannot be factored anymore. Cannot be factored, we call prime expression, or prime. So that's it. Let's see C. We see everyone has xy, and typically we want to factor out negative xy. Then the first term is multiply x. The second term we factor out negative xy. Well, factor out negative xy, that becomes minus negative, right? Then times y. Minus xy, then times xy. So every term has negative xy as a factor. So factor out negative xy. Then the first term left with x, second term left with y, the third term left with positive xy, because this one is positive. But if we choose this one to be negative, and this y has to be negative also, because the negative times negative positive. And this x, of course, is a positive. So x minus y plus xy inside parentheses, no more common factors. So that's it. Let's see 6. 6, also we want to factor out the greatest common binomial factor. So we have two groups. We have this group adding this group. And we see this is a factor in the first group, and this is a factor in the second group, right? Even is a binomial. So that means we can factor out x plus 2. Then the first one we left with the 2x. The operation is plus. And the second one we left with 9. And that's it. So that needs to be a binomial, multiplied binomial. And this is in the factored form because you have something multiplied by something. Let's see B. We have this group, we have this group. And we see this group has x minus y as a factor. This one also. So we factor out x minus y. Then we have 7 from the first group, and minus x from the second group. So now it's in a factored form. 7 factored by grouping. So let's group those two. We see the common factor of those two is x squared. So factor x squared with x plus 5. This one we see common factor is negative 3. Factor negative 3 will also have x plus 5. Because negative 15 minus negative 3, that's positive 5. Now we have common factor of x plus 5. So we factor out x plus 5. Then the first one we left with x squared. Second one we left with minus 3. Let's see B. Let's group those two, group those two. Common factor x. Then we have xy plus 1. Common factor of 3. We have xy plus 1. Now xy plus 1 is a common factor. So we have x left for the first one, plus 3 left for the second one. So now in a factored form. So factor out trinomial. So the first term is negative, so let's factor out negative sign first. Inside x squared is positive, and x becomes positive, but 12 becomes negative now. Then we think about two numbers, multiply to be negative 12, adding up to be 1. So that's x plus 4, x minus 3. Right? Because positive 4 times negative 3, that's negative 12. Positive 4 plus negative 3, that's positive 1. B is a prime. B cannot be factored. in real number. So just leave as it is. C, we're thinking about two factors multiplied to be 18y squared, adds up to be 9. That has to be 3 and 6, right? X plus 3y times x plus 6y. Because 3y times 6y, that's 18y squared. 3y plus 6y with x, that's 9xy. Let's see D. D, the first term only has one way to factor it, right? 2x and x. Then think about the negative 27. To play with these two to get the middle term 15. 27 can be thought as 3 times 9. Right? 2 times 9 is 18. 18 minus 3, that's 15. Bingo. So we want 2x times positive 9. So 2x times 9 give us 18x. Then we need a minus 3. So we have negative 3x. So 18x minus 3x, that's 15x. To factor out as these two binomials. Let's see, 9 and 10. So we basically want to factor this polynomial degree 2 trinomial. So how do we do that? We can think, so we're playing with factors of a and negative 15. So a can be factored out as 4 and 2. Okay. And 15 can be factored out as 5 and 3. So to play to get a positive 14, yes. So you will do positive 5, negative 3. So negative 3 times 5, negative 15. Okay. 4 times 2, that's 8. That's how we get this 8, this negative 15. Then we do more, 4 times 5, that's 20, positive 20. 2 times negative 3, that's negative 6. That's positive 14. That's the middle term, bingo. That means we can write our factoring as 4x minus 3 and 2x plus 5. If you want, you can, put an x in here, right? Then 4x times 2x, that's 8x squared. Then 4x times 5, that's 20x. 2x times negative 3, that's negative 6x. Then 20x minus 6, that's 14x. So this one factor to be like this, a binomial multiplied by a binomial. Now let's see this one. 5 only has one way to factor 1 and 5. So we have to think how to factor 12 to get a negative 16. To get negative 16, we need both to be negative, because negative times negative be positive. And then we get this negative adds up to be negative. So if we do 2 and 6, right? 2 and 6. So the 2 times, so this is x, this is x. 2x times 6x, that's 12x squared. Negative 5 times negative 1, that's positive 5. I multiply 2x with negative 5, get negative 10x. Multiply 6x with negative 1, get negative 6x. And those two adds up to be negative 16x. Bingo, right? So that means we can factor this as 2x minus 1 and 6x minus 5. Just write this way, 2x minus 1, 6x minus 5. Okay, last one, 10. Factor completely. First, we see everyone has 4 as a factor. And also every term has x as a factor. So let's factor 4x first. Then the first term becomes x squared. Second term becomes 6x. The third term becomes 5. Now think about two numbers. Multiply to be 5. add up to be -6. They can only be -1, -5, right? Because -1 times -5, +5. -1 plus -5, that's -6. So that's it, okay. So that's going to be today's class. I hope you have time to preview.